Let me open. Okay. And for this week, we are going to cover, or we will continue with for loops. And there's only one topic in for loops, which is nesting for loops. Then we will cover in that content. And after that, I'm planning to move to while loops. And we will see break or next comments. And also we will see the repeat statements in here. And I want you to get the idea of the differences between these three concepts, which are for loops, while loops, and the repeat statements, which is also another loop in here. And if we had enough time, if we have enough time in after that concepts in there, I'm planning to cover data cleaning and give you a brief explanation on there, okay?
Okay.
That sounds great.
Thank you. So, is your friends are here now, guys? Someone asked me.
Hocam hala girememiş de deniyor şimdi. Tekrar bağlanmayı deneyecek.
Okay.
Hocam bir şey daha sorabilir
Hocam
miyim?
geldim buradayım.
Okay, sure.
Hocam bir şey sorabilir miyim? Ayşegül böldüm ama o class'taki link doğru link değil galiba. Doğru muyum? Onunla
Hayır.
bağlanılmıyor da.
Class'ta sadece restation
oradan
linki.
bağlandım.
Yo doğru, sizin dersinizde var.
Actually, I used that link, and also Matt told me he used that link too.
Yok, ben ilk mail attığınız linkten bağlandım. Diğeri bağlanmıyor çünkü de bir haber vermek istedim size de.
So I generated a link for each week. Maybe it may be a better idea to use that.
219'un duyurularında sağ tarafta lecture link var. En aşağıdaki kocaman böyle büyük harflerle yazıyor.
Thank you, Mert.
I was gonna ask something just because before the lecture starts, like officially.
So, we are going to cover nesting for loops, and in here, and we will have two loops in this example, and one of them, the inner loop, is nested in the outer loop, okay? And the inner loop is executed in full before the outer loop index is incremented, at which point the inner loop is executed all over again in here. So maybe it's going to be more clear for us, guys, after I cover this example. Let's first generate this vector together, and this is going to be my first vector from, let's say, 5 to 7. And also let's generate loop vector 2, which is from 9 to 6. So right now I have two vectors. Now I want to generate an empty matrix, and which is NA, and the number of rows is going to be length of the loop vector 1, and the number of columns is going to be the length of loop vector 2. When you just run this part, you have an empty vector, I mean the matrix in here. Here is my full matrix. And now we will try to fill this matrix by using the elements of the first and second vector in here, okay? So what we are trying to do in the following nested loops is that we want to fill full matrix with the result of multiplying each integer in loop vector 1 by each integer in loop vector 2, okay? Let's start. Here is my first for loop. I will start with my first for loop in here. We will just add an index for the first one, and I is 1 to length of loop vector 1, okay? This is going to be having each indexes for loop vector 1, and inside this loop, I'm going to generate one more loop in here, And this time we have another index, and this loop index has to be different than the first one. For example, this one is I, and the second one cannot be I. You have to give another name in here. And now also J is going from 1 to length of loop vector 2, okay? So please remember, we were aiming to do some multiplying of each integers in these two vectors. And now let's start filling each element of my matrix by getting loop vector 1, ith element, and loop vector 2 and the jth element in here, okay? And right now I have my for loop, and now this loop is going from I to length of the first vector, and which is going to be 3. And from 1 to 3, you will see that, maybe you remember the foo matrix has 3 rows. So for ith rows, and it's going by row first, and after that, inside that loop, we are going from J to length of vector 2, which is going to be 4. And now for each vector, and after that, each column, each row, and then after each column of this row, you are just multiplying the elements of the first and the second vector. And when I run this for loop, you will see now I have a filled matrix right now. Please remember, each of your nested loops require a unique loop index for each use of for, okay? Just unique indexes. You see ith and j. And we are just using them once. And the loop index is I for the outer loop and j for the inner loop, okay? So when you just execute the code, I is first assigned 1. The inner loop begins, and then G is also assigned 1. So I is 1, J is 1, okay? The only command in the inner loop is to take the product of the ith element of loop vector 1 and the jth element of the loop vector 2 and assign it to row I and column J, okay? The inner loop repeats that job until J reaches the length of loop vector 2, which is 4, and fills the first row of foo, then I increments. And the inner loop is started up again. The entire procedure is complete after I reaches the length of the vector 1. And the matrix is filled. So for the first step of your loop, I is 1, J is 1. Then I is 1, J is 2. I is 1, J is 3, I is 1, J is 4, okay? So you are going by elements like this. And then you are at the maximum of your length 2, and now I is 2. You have 1 increment in your outer loop. And now you are going to this element to the 4th. And after that, you are going to outer loop, and again, your I is 3, and you are going 1 to 4, okay?
Professor, I tried doing this, but I don't know why, for some reason, like I have the first column, right? But
so for this part, we will cover the while loops. It is another type of loops in here, and you are starting in somewhere with a condition, and until your condition true, you are running your statement, and when your condition is false, you exit. And maybe if you are, remember the for loops, you have to give the exact number of your steps in for loops, okay? And you should say in how many times your loop will be repeated. But in some situations, we don't know how many times we are going to repeat our loops in here. We just run a while loop in this case. We can just give a condition in here, and while loops runs and repeats while a specified conditions is true. And the general sense in here is something like that. You have while, you are going to write your loop condition, and you will do any code in here, okay? Did you get the idea? Do you have any questions, guys? Did you get the difference between for loops and the while loop?
Yes.
Yes.
Okay, that's a good sign. So let me share my R screen in here with you guys. Where is my R Studio? There we go. And here is my R Studio. Are you able to see that part?
Yes.
We can see it, yes.
Okie dokie. Now we are going to write another example by using while loops in here. Let's write while. And now instead of for, we will use while loop because we don't know how many times we are going to evaluate our loop in here. And now I want to give a value first. Here is my value as 5, and I want to save my file in somewhere. Yes, I save it first. And I have a value now. And while, here is my condition, my value is smaller than 10, let's say it is 10. I want to do what? I will do my while and equals my while plus 1, okay? And I want to say cats. Okay, okay. Cat n, and say my while is now something. My value, and I will go to the next line. And after that, I want to write something else, and we will say that right now my condition is now, here is my condition, my while smaller than 10, and I will go to the next line. Okay, now you have your value as 5. So for each step, you just get your value plus 1 and just write these parts. And now you will get the idea. Now for the first step, your value, my value is 6, and my condition is true. And in here again, my value is 7, my condition is true. And when it just finds the false condition, it stops there. So what does it mean that this while loop uses a single logical valued loop condition to control how many times it repeats, okay? Then upon execution, the loop condition is evaluated. If the condition is found to be true, if your condition is true in here, the braced area, that means this part, this part is executed line by line as usual until complete. And at which point the loop condition is checked again. The loop terminates only when the condition evaluates to false. When it finds the false, it does so immediately, and the braced code is not run one last time, okay? So when I find the false in here, I stop there. I don't go over for the next level. You can see it in here. When you just find the 10, and it just stopped there, and now your condition is false, okay? So we can see some more complicated settings, and so it's sometimes useful to set loop condition to be a separate object so that you can modify it as necessary within the brace area in here. So we will use a while loop to iterate through an integer vector and create an identity matrix in here in this example with the dimension matching with the current integer that we will give to our while loop. And this loop is going to stop when it reaches a number in the vector that's greater than 5, okay? Or it just ends when it finds at the end of the integer vector. So let's start with the second example. And we have another example in here. I'm going to generate a list first, an empty list, okay? So why we are doing that? Because we will try to fill in this list in my while loop. And first of all, I have an empty list. Sorry guys, this has to be list, of course. And so maybe we should go over to this example after the break, okay?
Okay.
It's already
Okay.
I'm out of time. Resume recording. So we will cover another example with you by using while loop in here. And first of all, we generated an empty list in here. For each step, we will try to fill this empty list. And let's write a counter as starting 1. And let me give you a vector. We will use this vector inside our loop. 4, 5, 1, 2, 6, 2, 4, 6, 6, 2. Sorry, 2. And also for these settings, and we will use a while loop which is going to iterate through an integer vector. Here is my integer vector. And this is going to create an identity matrix with the dimension matching the current integer. For example, if we are in this element, we will have 4 times 4 identity matrix. And this is going to stop, this loop stop when it reaches a number in the vector that's greater than 5, or when it reaches the end of the integer vector. So I want to just write the condition not inside the loop, but just as a separate object, and I can modify when it is necessary, okay? So here is my condition. Please get the idea that we are not putting that inside our condition, and we are just generating a separate object so that we can modify it as necessary within the braced area, okay? So here is my condition and my number. Here is my numbers, and I will get that vector. For each counter, we will check if it is smaller than 5. Here is your condition. So let's start writing our while loop. And my condition is this one. I already said what is the condition before. And for my list, for each counter, we will generate a list element. And for this diagonals, we will have my numbers and add the counter. And so what is going to do is that, for example, for counter 1, as for the first step, and this is going to go and get the first element from here. And since it is 4, it is smaller than 5. And this condition will be run. And then you will see that we will have 4 by 4 diagonal matrix as a first element of our list in here. And after that, of course, we should do something to say that the counter has to stop somewhere. If we don't, then this is going to be give you an error in here. And if counter is smaller than the length of your numbers, the vector in here, then my condition right now is the same as before. My numbers counter smaller than 5. And we have an else statement. For anything else, my condition is going to be false. Okay. So I have my empty list. I have my counter starting by 1. I have my numbers vector with 2, 4, 6, 8, 10 elements. I have the condition in here. And now, starting with this for loop, I mean the while loop, it is just checking for, did I do something wrong? I guess so. My list counter the diagonal element. No, we don't have counter equals counter plus 1, guys. Did you see what did I do? Of course, for each step, I should have counter equals counter plus 1, okay? Sorry for that. So we have an empty list, again, counter, condition, and this one. Now, when you check your list, you will see that you have, for example, 4 by 4, 5 by 5, 1 by 1, and 2 by 2 diagonals in here. Okay. This is okay. This is kind of complicated. Maybe we should talk some little more about this condition. So then you should just digest that part, okay? And in this loop condition, my condition is set what? True or false as a first step?
True.
It's true.
Yes, that's going to be true because the first element of my number is less than or equal to 5 in here. And inside the loop, beginning at while in here, okay, the first line use double square. Do you know why? Because we are indexing our list in here. And the value of counter to dynamically create a new entry at that position in my list, okay? So this counter is going to be 1, 2, 3, 4, 5 to 10. And now for each of them, it's just getting and giving the position, and this entry is assigned an identity matrix whose size matches the corresponding element of my numbers, okay? And the next line is just counter is incremented, and now you have to update your condition in here. You want to check whether your number is smaller than 5 again. And you also need to check whether you have reached the end of the integer vector. Otherwise, you can end up with an error by trying to rewrite an index position outside the range of your numbers in here. Okay. So you can use an if statement to first check the condition. And if true, then set my condition to the outcome of my numbers, counter smaller than 5. If not, this means you have reached the end of my numbers. So you make sure the loop exists by setting my condition false in here. Okay. So this is going to be until my counter is smaller than your length of numbers in here. And then eccentric example. Maybe you should practice this part by yourself and just digest this example and try to get the idea step by step, okay?
Okay.
And something I will do is that I will remove everything. After that, I will just close that part and try to get the idea what happens if I don't use this part, okay? Just run without this code and just practice it without, with and without, and see that you will get an error message if you don't use this condition in here. This is not so common to use, but it's good to know in here to use if clause inside while loops, you know, use conditions and loops together. Okay, guys?
Okay.
Thank you. So now we will see something more easy to understand. And so in R, you can just you can change your normal looping sequence by using the break or next statements in here, okay? And when you use the break statement inside a loop, it can be repeat, for, while, and this is going to stop the iteration and flow the control outside of the loop, okay? Let's see an example, and this is going to be much easier for you to get the idea. And let's generate a vector first, x from 1 to 5, and for your value in x, if your value is 3, then, oh, sorry, guys. Is 3, then break. If not, print my value, okay? So I have a vector from 1 to 5 in here. So for each of these value in x, I will check if it is 3, and if this is true, then we will break. Otherwise, we will print. You will see that we have 1, first 1, then 2, and so when it comes to 3, you just see the break, and then R just stop there, and your iteration is stopped, and you just plow the control outside of the loop, okay? I think this is not so hard to get the idea. It's kind of a cheesy one. And also we have another statement which is next. And when you use the next, R is going to skip the current iteration of a loop without terminating this time. Maybe you will see that in here, R is terminating when it sees this value, but for next, it is going to skip the current iteration of a loop without terminating it. And on encountering next, the R parser skips further evaluation and starts next iteration of the loop in here. We have a very, very similar example. Let me just copy and paste. So again, we have x. For value in x, if value equals 3, instead of break, we are going to use next this time. And when we just run this part, you will see that that's kind of fancy. When our C3, it just skip that line and just run the rest of the code, okay? So you can use one of them depending on your aim on your programming, okay? You can just break the loop or skip one step of the loop. These are two options that you may want to use, break or next. Did you get the idea, guys? Do you have any questions?
Yes.
Comments? Yes. Okay. So let me share some portion of my Yes. So, are you guys see this part?
We can see it.
Yes.
Perfect. So this time, instead of for loop and while loop, we are going to use repeat. Now you also again has some repeat loop, and you want to iterate over a block of code multiple number of times. So you have your condition. If it is false, you are iterating. And if it is true, you just break. It's kind of opposite of while loop, okay? And so here is how we use that one. This is the pseudocode for repeat. And here is our general definition. So we will see an example and get the idea how it is working in here. Let me first. Are you guys able to see my R screen
Yes.
now?
We can
Yeah.
see it.
Yes.
Perfect. Let's go to the repeat statement in here too. So first, let's generate a value, which is x, and we want to repeat something. So please print x, and for each step, you have an increment for x by 1. And if x is 6, then please use break in here. Okay. Now we have x equals 1. We are going to repeat this printing part by the incrementation in x by 1. And if x is 6, then it's going to break. And here is what is happening. A repeat loop is used to iterate over a block of code in here. And this is going to be multiple number of times, of course. And there's no condition check in repeat loop. It's just repeating, okay, to exit the loop. So we must ourselves put a condition in here explicitly. And this should be inside the body of the loop and use the break statement to exit the loop. So it's kind of using repeat with break. And if you do not add break in here, and you will go to an infinite loop in here because repeat doesn't know where to stop. Okay.
We can also use next here, right?
Why not?
Okay.
So if you use next, you will go to infinite loop again, I guess. Because repeat is looking for something to break. So then maybe we have to add the break in here, okay?
Yeah, I meant in another condition. For example, just print the odd numbers maybe, and when you come to 6, then break.
Ah, yes, maybe. So here is what we have done so far. Sorry, guys. So we have seen our for loop and while loop and repeat. And this is kind of giving a brief summary about these 3 types of loops. You can use one of them for your problems. And generally, they are embedded in a function that you can just mix them with a function and use them inside the function. Then we will see them for the next lecture. And so for all of them, maybe for loops, for example, you have to start with an initialization in here. And then it's going to check for the last iteration, okay? And generally for while loops and for repeat, we are just giving a logical condition. And for while loop, it is just looking for if it is true. And then it just run your statement when your condition is true, and it stops when it finds the false. And the repeat is just different than the while loop. It's just looking for your code block, and your logical condition is just running when it is false. and stop when it is true. Okay, this is the summary for the loops in here.